In the BJT amplifier, the frequency effect introduced by 1. The larger capacitive element of the network at the low frequencies. Second, the larger capacitive elements of the active device at high frequency. The analysis will extend through a wide frequency range. Therefore, the logarithmic scale will be used throughout the analysis. Okay, you have to remember these two things. For the low frequency, because of the capacitive elements at the network, and for the high frequency, it is because of the larger capacitive element of the active device. Okay, next, the BJT amplifiers are filled with RC coupled circuit, an active device where the low, mid and high frequency will give effect on the gain of the amplifiers. Okay, remember that the low, mid and high frequencies will give effect on the gain of the amplifiers. So below is the illustration of a gain versus a frequency plot. This is the gain. The AV is a gain, and for the X scale is F log, in a log. This is what I said in the previous video, that we use log scale for the frequency. Okay, for the first thing, why we need to use log scale? Okay, this is because the range of the frequency is too high. Okay, as you can see, it starts from 10 here until 10 megahertz. If we are using only normal paper graph, it is impossible to fit all scale or all range in one pieces of a paper graph. So we need a larger scale, so that's why the logarithm is really suit for this graph. Okay, let me see what happened for the gain during the amplifier, our amplifier. Okay, for this one, okay, take a look here. Okay, the AV low, at this time the gain is low. It start from 0 and increase until 0.707 here. Okay, if you can see here, the maximum gain is 1 at AV mid. Okay, this is the maximum gain AV, and it reduce here. Okay, so the AV low gain at low frequency due to the coupling capacitor for this one. Okay, this is what it means by the network. Okay, and at the AV mid, the maximum gain at the middle frequency. Okay, so we say that here is a middle frequency, so we get a maximum gain or equal to 1. Okay, then AV, the gain is at high frequency due to parasitic capacitance. Okay, the AV high here, the gain AV high, okay, the gain is dropped again from here. So this is because of the parasitic capacitance of network and active device. Okay, an active device and frequency dependent on the gain of the transistor BJT. So active device here is a transistor BJT. Okay, so this is the difference. Okay, the first one, the gain will be low at the low frequency due to coupling capacitor. Okay, second one, the gain is low again at the high frequency due to parasitic capacitance. Okay, this parasitic capacitance is mostly inside the active device, which is the BJT, and a little bit from the network. Okay, then the bandwidth. Okay, we calculate the bandwidth when we get this cut-off frequency. F1 is a low cut-off frequency, then F2 is high cut-off frequency. Okay,